Hi there, my name is Dimitris Haralambidis, and in this video we will continue our references on binomial expansion, and we will continue from the fact where we should simplify a binomial expansion. So far in the previous video, we learned that by binomial expansion, we mostly mean how we can expand. Let me rewrite that in a better way. How we can expand the a plus b to the power of n, and we saw that this can be through this formula, 0 n plus n1 a to the power of n minus 1 times b to the power of 1 plus n2 a to the power of n minus 2 times b to the power of 2 up until the last term, which would be of the form n a to the power of 0, b to the power of n. And we said that with regards to that, if we simply carefully apply this formula, we are done with the expansion part of the exercise. Now, in most cases, however, we might be asked to not only expand the binomial, but also simplify. In this case, it's all about operations. And mostly among the operations done, first of all, we have some properties of powers of the exponents, because we work with exponents. It should be one of the properties, a to the power of n, and all that to the power of n is a n times m. A to the power of n multiplied by a to the power of m is a n plus m. A to the power of n over a to the power of m is a to the power of n minus m. And of course, a to the power of 1 is equal to 1, since this is an axiom. This is about the exponents. Now, we have not yet mentioned what these forms here are. They are called combinatorial numbers. They read as n choose k. And why do we read them like this? Because they show how from a set of n items I can combine different items per groups of k. For example, if in a class of 15 students, I want to elect 3 of them for a committee, there are 15 choose 3 different combinations of 3 persons committees. What is the algebraic expression, however, for this combinatorial number? It has a formula as well. N choose k is given as the quotient of n factorial over k factorial times n minus k factorial. And this is weird because some of you might see this factorial for the very first time. N factorial reads n factorial is equal to the product of all successive natural numbers starting from 1 up to n. So n factorial is 1 times 2 times 3 times 4 up until n. And if you don't quite understand what the significance of n here is, let's see some examples. 3 factorial should be 1 times 2 times 3, which is 6. 5 factorial should be 1 times 2 times 3 times 4 times 5, whatever that is. 100 factorial should be a huge number, but it's just the multiplication of 1 times 2 times 3 times 4 times 5 times 6 up until 100. One interesting thing is that 0 factorial is equal to 1, and that serves as an axiom as well. Now, example. Let's expand 5, choose 3. Based on what we mentioned, it should be 5 factorial over 3 factorial multiplied by their difference factorial, which is 5 factorial over 3 factorial times 2 factorial. Instead of expanding them, I can apply a property. N factorial is the same as n minus 1 factorial times n. If you don't get that, look an example. 6 factorial can be written as 1 times 2 times 3 times 4 times 5 times 6, but I can group the product of 1 times 2 times 3 times 4 times 5 into the 5 factorial, and I can have it written like that. Where can this be handy? Instead of 5 factorial and instead of expanding that as 1 times 2 times 3 times 4 times 5, I can write that as 3 factorial, which is the combined way to describe the 1 times 2 times 3, multiplied by 4, multiplied by 5, over 3 factorial times 2 factorial. In this case, the factorials can be cancelled out, and we would be left with 20 over 2, which is 10. So overall, let's remember the significance, the interpretation of that. 5 choose 3 shows how many ways are there in order from 5 items, assume that these are 5 persons, to collect different groups of 3 persons each. There are 10 such groups. Moving on. Apart from this formula, there is another way that is way quicker and allows us to calculate combinatorial numbers, but there's a catch. It is quite helpful for cases where we don't need to overdo that. It could be really quick to allow us to calculate the combinatorial numbers of 4, 4 choose 0, 4 choose 1, 4 choose 2, 3, and 4, but not that easy if we wanted to calculate the combinatorial numbers of 10 choose 0, 10 choose 1, and so on. And let's see why is that. This, first of all, has a name, this process. It's the Pascal's triangle. It starts with 1. Then it goes to 1 and 1. Then it goes to 1, 2, 1. And then it goes to 1, 3, 3, 1. By just looking at that, can you figure out what the next line should be? If we pay attention, we might see that what it does basically is adding these two. 1 plus 1, 2. Then 1 plus 2, 3. 2 plus 1, 3 again. So the next one should have been 1. And this time we should add these two. 1 plus 3 should be equal to 4. Then 3 plus 3 should be equal to 6. 3 plus 1 should be equal to 4 again. And we end up with 1 at the right bound. Similarly, the next one would have been 1, 5, 10, 10, 5, and 1. The interesting part, however, for these numbers is that they are not just numbers. They express the combinatorial numbers. We see 2 here, so this line should describe the combinatorial numbers of 2. 2 choose 0, 2 choose 1, 2 choose 2. We have 3 here, so this line describes the combinatorial numbers of 3. 3 choose 1, 3 choose 0, 3 choose 2, and 3 choose 3. Similarly, we have 4 here. So this line's numbers express the combinatorial numbers of 4. 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4, and so on. So this is a quicker way to calculate the combinatorial numbers without the need of over repeating the formula. Let's see some examples. Expand and simplify 2x plus 3 and all that to the power of 4. At first, we will do the expansion part. The expansion part simply relies on applying the formula. It's 4, 0, 2x times 3 plus 4, 1, 2x times 3 plus 4, 2. I'll put the exponents at the next step. 2x times 3 plus 4, 3, 2x times 3 plus 4, 4, 2x times 3. Now it's time to put the exponents. Remember that whatever the number is down there, the same will be the exponent of b, in this case, number 3. It's 1, it should be 1. It is 2 down there, it should be 2. It is 3, it should be 3. It is 4, it should be 4. Then, with regards to the powers of a, of 2x in our case, we should put the number which, if properly added to the corresponding exponent of b, they will always produce a sum of 4. It should be 4, 3, 2, 1, and 0. This line stands for the part of the expansion of the binomial. With regards to the expansion, we are done. That's it. Now we need to see how we can actually simplify that. To do so, we need to apply properties of powers. And another property we didn't mention was this property. A multiplied by b and all that to the power of n is this. And of course, we need to calculate the combinatorial numbers of 4. I can do that really quick by remembering that I just need the Pascal's triangle. I need to write that until I find number 4. 4, 6, 4, and 1. So this should be 4 choose 0. This should be 4, 1. This should be 4, 2. This should be 4, 3, and that should be 4, 4. Let's now substitute them. 4 choose 0. I found it through the Pascals. It's 1. 2x and all that to the power of 4, that can be written as 2 to the power of 4 multiplied by x to the power of 4 multiplied 3 to the power of 0 is 1. Plus 4 choose 1 is 4 multiplied by 2 to the power of 3 times x cubed times 3. Plus, in order for you not to get lost, let me highlight the corresponding parts. This was substituted by that. This here was substituted by that. Now I'm trying to substitute all that. Based on the Pascal's triangle, 4 choose 2 is equal to 6. Multiplied by 2 to the power of 2, x to the power of 2, times 9. So that was this. Then I should expand this part. So 4 choose 3 is equal to 4, multiplied by 2 times x times 27. Let's highlight that again. Plus 4 choose 4 is 1 times 1 times 81. 3 to the power of 4 is 81. And this is that. Now, all that is left is for me to do some calculations. 2 to the power of 4 is 16. This is 16. So 16 times 1 times 1, it should be 16 x to the power of 4. 2 to the power of 3 is 8. 4 times 8, it's 32. 32 times 3 should be 96. So 96x cubed. 2 squared is 4. 4 times 9 is 36. 36 multiplied by 6 should give me 216 plus 216x squared plus 4 times 2, 8. Multiplied by 27, it's again 216x plus 81. This is the simplified form of my original binomial expansion. Let's do one, let's call that harder example. Expand and simplify x squared plus 1 over x to the power of 3. I'll begin, like I did before, with the expansion part. It should be 30 x squared 1 over x plus 31 x squared 1 over x plus 32 x squared 1 over x plus 33 x squared 1 over x. Then I'll continue with the exponents. It's 0 down there, 0 up there. 1, 1, 2, 2, 3, and 3. And then the powers of a of x squared, so that they both always add up to 3. 3, 2, 1, and 0. Now I need to calculate them. The two properties of powers that it seems that I will be using here are the one of a to the power of n, and all that to the power of m is a n times m, and a over b, and all that to the power of n is a to the power of n over b to the power of n. Also, I need the combinatorial numbers of 3, so I'll quickly do the Pascal's triangle up until I reach the line that includes 3. This is 3, 0. This is 3, choose 1. This is 3, choose 2. And this is 3, choose 3. Let's start. I'll begin by expanding the first part. 3, choose 0, based on what I got from Pascal's triangle, is 1 times x to the power of 2, and all that to the power of 3 is x to the power of 6 times 1. So this is the yellow part. Let's continue to the green one. 3 choose 1 is 3 times x to the power of 4 multiplied by 1 over x. That was the green part. Next, let's continue with the blue one. 3 choose 2 is 3 again times x to the power of 2 times 1 over x to the power of 2. That was the blue part. And finally, the pink one should be plus 1 times 1 times 1 over x cubed. I still need to do, however, operations to even simplify it further. 1 times x to the power of 6 is x to the power of 6, multiplied by 1 again, it's x to the power of 6. Plus 3 times 1 is 3, x to the power of 4 over x, based on this power, on this property, I should keep x and find the difference between 4 and 1, x to the power of 3, plus 3, and these are cancelled out, plus 1 over x cubed. This is the simplified form expression of the binomial x squared plus 1 over x to the power of 3. So let's do a quick revision on what we just saw in this video. Remember that when we are given a binomial and we are asked to expand it, we simply apply its formula. When we are asked to simplify that, we need, after having written the formula, to carefully calculate the combinatorial numbers. Most likely we will need to just apply the Pascal's triangle, not the formula, but you should know, however, how to apply the formula as well, and carefully apply properties of powers. Then it's all about operations. That's all for now. For any questions you might have or any concerns, feel free to leave your comment below. As always, thank you for your time.